In this video, we're going to take a look at an introduction to sequences, and in particular, we're going to talk about arithmetic sequences. First, let's look at a little bit of vocabulary. A sequence is what we know as an ordered list of objects, terms, or events. A set is a collection of distinct, well-defined objects forming a group, and each item in a set is known as an element of the set. A term is a single number or variable, or the product of numbers and variables. And finite versus infinite. Finite sets have a countable number of elements, while infinite sets do not. So what is an arithmetic sequence? An arithmetic sequence is a set of terms where the difference between each pair of consecutive terms is the same. So let's fill in. It's a set of terms. And then when we notice it has the difference between each pair of consecutive terms is the same, we call this number the common difference. So let's just look at a few examples and pick out the common difference. If we see the sequence 2, 5, 8, 11, 14, and we want to figure out what is the common difference. You want to see, like, how do I get from 2 to 5? So from 2 to 5, I could add 3. And then from 5 to 8, I notice I could also add 3. And then 8 to 11 is the same. I can add 3. And then to go from 11 to 14, I can also add 3. So it looks like that would be our common difference, would be to add 3. Let's look at another example. From 7, 3, -1, -5, let's try to figure out the common difference. So to go from 7 to 3, we're getting smaller. So that looks like we have to subtract 4. So let's see if we can also subtract 4 to go between the next two terms. So is 3 minus 4 going to give us -1? Yes, so that's the same. And then to go from -1 to -5, we could also subtract 4. And so it looks like our common difference this time is to subtract 4. And then let's look at another one. We go from 4 to 9, there's supposed to be a comma there, to 14, to 19, to 24. So the numbers, you can tell, are getting bigger. So to go from 4 to 9, I would need to add 5. And to go from 9 to 14, I can also add 5. Then if I add 5 to 14, I get 19. And to add 5 to 19, I would get 24. So it definitely looks like our common difference for the third one is to add 5. Let's write down a few more terms that we need to know what they mean. So D is the common difference. Let me just scooch that over in that box. A sub 1 we know as the first term in a sequence. So that's how we name it, is A sub 1. That indicates the first term. So A sub 2 would be the second term in the sequence. So therefore A sub n means like the nth term in a sequence, something we might be looking for. And then A sub n minus 1 is the previous term. So let me grab another color. That is the previous term. All right, so jot those down. And then I've already pre-typed in what the explicit formula and recursive formula are, so that way none of the little details get lost in translation. So the explicit formula is useful for finding any term in an arithmetic sequence. And you have A sub n is equal to A sub 1, which is our first term, plus n minus 1 times D, which is our common difference. So A sub n is the nth term in the sequence. That's typically what you're looking for. A sub 1 is the first term in the sequence. D is the common difference. And n is the same number in both of those two places. All right, the recursive formula is useful for finding a term when you know the previous term. So A sub n is still our nth term. It's equal to A sub n minus 1, which is the previous term, plus the D, which is the common difference. So let's take a look at just a few more examples. So given the sequence 7, 18, 29, 40, let's first determine what the common difference would be. So it looks like these numbers are getting larger. So to go from 7 to 18, I would add 11. And then check and make sure that would be the same. So 18 plus 11 does give me 29. And 29 plus 11 would also help me to get 40. So our common difference is to add 11, or it's positive 11. So I'm going to jot down the recursive formula and the explicit formula from the previous page in these boxes. So the recursive formula is a sub n is equal to a sub n minus 1 plus d. And the explicit formula is a sub n is equal to a sub 1 plus n minus 1 times the common difference d. Okay, so now I can focus on my example. So remember, the recursive formula is great if you have the previous term and you just need like the next term in the sequence. And the explicit formula was useful if we can find any term in the sequence, we can use the explicit formula. So if we want a sub 5, that would be the 5th term in the sequence. So I count that I have 1, 7 is my first term, so that's like a sub 1. 18 would be a sub 2. 29 is a sub 3. 40 is a sub 4. So I do have the previous term to a sub 5. So I could just use that recursive formula to figure that out. So I'm going to say a sub 5, well, that's already typed there, is equal to the previous term, which is a sub 4, which is equal to 40, plus the common difference, which we found was 11. And I think, I'm trying to make sure I manage my space here. This formula we can actually make nice and big and add it to this box right here, because I have all the room I need underneath there to say a sub 5, the 5th term in our sequence, would be 40 plus 11, which would just equal 51. All right, and then the same thing over here. I'm gonna move this explicit formula down to this box and make it nice and big. So if I want to figure out the 150th term, that's pretty big. I don't have the previous term, so it would take me a really long time to use the recursive formula to figure this out. So instead, it would make more sense for me to use the explicit formula. So I want to figure out the 150th term. So I need the first term, so that was 7, plus n minus 1. So n is the number of the term you're looking for. So that would be 150 minus 1 times the common difference of 11. So then it would probably help to use a calculator. So let me grab Desmos and just type that right in. So let's do 7 plus 150 minus 1 times 11. And we get 1,646. So the 150th term of this sequence would be 1,646. So that would have been a lot to calculate just by hand, but we have our calculator. All right, let's look at another example. So given the sequence negative 50, negative 56, negative 62, let's figure out what the common difference is. So they're getting larger, but they're negative. So technically they're getting smaller. So negative 50, I would have to subtract 6 to get to negative 56. Then I would also have to subtract 6 again to get to negative 62. So the common difference would be minus 6 or subtract 6 or negative 6. And then what I always think when you're practicing your formulas, you should just write them every time you're working a problem out, so you just naturally start to memorize it. So let's write down that recursive formula again. So a sub n is equal to the previous term, so a sub n minus 1 plus the common difference. That's the one that's helpful if you know the previous term and you just need the next term. And so in that case, that would help us to figure out a sub 4, because we know a sub 1, the first term, is negative 50. A sub 2 is negative 56, and a sub 3 is negative 62. So a sub 4 would just be the next one in the sequence. So it would be easy to plug into our formula and say the previous term was negative 62, and then we just need to add the common difference, which was negative 6. Or you could just say you have to subtract 6 from negative 62, and you get negative 68. Okay, so let's look at the explicit formula. Remember, this one helps if you need any term. And then it's always good to write your formula down as you work these out until you've got it down pat. So a sub n equals a sub 1 plus n minus 1 times the common difference d. So I'm going to use that one to figure out the 19th term because we do not have the 18th term, and that would take a little while to get there. So this is going to be helpful. So a sub 1 we know is equal to negative 50. We can add n minus 1. So remember, n is the number of the term you're looking for. So that's just the 19 minus 1 times the common difference of negative 6. And then we can just pull up our handy calculator and type that right in. So let's say negative 50 plus 19 minus 1 times a common difference of negative 6. And we get negative 158. All right, so let's just look at one more good example. So let's write the recursive, well, let's first look at our sequence. So we have the sequence 18, 14, 10, 6, 2, and negative 2. So the common difference, it looks like it's going down from 18 to 14 to 10 to 6. So it definitely looks like we're subtracting 4 each time. And that fits. So the common difference would be minus 4 or subtract 4. Let's write out our recursive formula again. So a sub n is equal to the previous term, which is a sub n minus 1 plus the common difference d. And then would that help us figure out the 7th term or the 45th term? So it looks like we've got the first term, the second, third, fourth, fifth. Looks like we have the 6th term. So that would definitely help us just to figure out the 7th term since we have the 6th term. So a sub 7 would equal a sub 6, which we know is that last one in our sequence we were given, which is negative 2 plus the common difference of negative 4. So negative 2 plus negative 4 would give us negative 6 for that 7th term. Now let's write out the explicit formula and see if that would help us with the other part of our problem. So a sub n is equal to the first term, which we note is a sub 1 plus n minus 1 times the common difference of d. So a sub n, remember n is your 45, equals a sub 1, which we look over here, that was 18, plus, so we type 45 is our n. Here, I'm just going to write that over here. 45 is n minus 1 times the common difference of negative 4, which we figured out in the beginning of the problem. So let's just type that in the calculator. Let's see. So 18 plus 45 minus 1 times negative 4 gives us negative 158 for the 45th term. All right, so I think that's enough few examples to get you started.